So up to this we covered equality operators, arithmetic operators, concatenation like. Now the next operator what we are going to discuss, keep subheading instance of operator. Instance of. Now instance of, why the capital or lowercase, uppercase or lowercase? Instance of lowercase or uppercase? Make sure, so compulsory it should be lowercase. Instance of operator. By mistake if we use capital O, compile time error by default we are going to get. Make sure instance of operator. Sir, what is the purpose of instance of operator? Where we can use this operator, right? Sir, I have an object is there. This object is of particular type or not? This object is of particular type or not? To check that, we should go for instance of operator. Sir, I have one object. This object is of particular type or not? Then we should go for what? Instance of operator. Then immediately you may ask, sir, if we have object without knowing the type, if we have object without knowing the type, how we can? Is nothing but maybe a chance. Just observe this point well. Here just have a look once. I have one array list is there now. Legend this one. This is the collection, array list is there. Collection, array list is there. Now the target is, okay, here I have, okay, object, first object, second object, third object, fourth object, dot is there. Can you tell what is this object is of what type? This object is of what type? It may be a string object, it may be integer object, or it may be is nothing but any object type. We can't tell, sir, this object is always a string type, this object is always a customer type or student type, is nothing but we can't. Now make sure a bit carefully. If we don't know this object is what type, okay, this is, that's why the return type of get method is object. It can be any object, that's why. So I want to get first object L dot get of 0. L dot get of 0. The object present at 0th index we are getting. This object is what type? It may be student object, customer object, or string object like. That's why. So here I am taking object O. Is nothing. So parent reference can be used to hold any object. Correct or not? Any object. That's why object O is equal to L dot get of 0 is nothing but like if O instance of, if O instance of student, sir, if it is a student type, okay, then typecast to student form. Student S is equal to student of, student S is equal to student of O, okay, like perform student specific functionality, perform student specific functionality is nothing but like we can take. Are you getting? Perform. Sir, if it is a student type, perform student specific functionality like else if O instance of customer. Sir, if this object is of customer type, internal object is of customer type, then customer C is equal to customer of O, customer C is equal to customer of O, perform customer specific functionality, perform customer specific functionality is nothing but like we can take. I hope that I hope you people can aware clearly what is the purpose of instance of operator. Sir, I don't know what is the underlying object. If the underlying object is of student type or not, if the underlying object is of customer type or not, if you want to check, then we can go for which operator? Instance of operator. Is that analogy very clear for you, right? What is the purpose of instance of operator? Is that clear at this point? We can use instance of operator. We can use instance of operator. We can use instance of operator to check whether the given object is of particular type or not. To check whether the given object is of particular type or not. Okay, take this example now. So the example which is helpful. So one scenario where instance of operator is required. Take this example clearly. So what is the purpose of instance of operator? And so array list object can be any type, we don't know. It may be string type, customer type or student type. I want to check if it is a student type or not, whether it is customer type or not. Then we should go for what? Instance of operator, right? So to check whether the particular object type or not, like. Completed clearly, right? Yes. Okay. Perform customer specific functionality. Perform student specific functionality like we have. Next one. Completed. Okay, here just one scenario where instance of operator is required. Okay, we covered anyway where instance of operator is required. This is one scenario, right? Now the next point, here just observe what is the syntax and what are syntactical loopholes. Sir, are instance of some x. Sir, what is the syntax? Okay, what is the syntax for instance of operator? Just listen. R instance of x. Can you tell what is the R? R is what? Object reference. R is what? Object reference. X is what is the x? X is any class or interface name. Either class name or interface name. First take the syntax. R instance of x. R instance of x. What is R? Object reference. What is x? X class or interface name. Class or interface name. So example 1. Just observe example 1. Sir, I am taking thread T is equal to new thread. Thread T is equal to new thread. Here I have one thread object is there. Thread object is there. Do you know thread is child class of object. Thread implements runnable interface. I hope you may be aware. Runnable interface. Thread is the child of object. Now my target is system.out.println SOP of T instance of thread or not. T instance of thread or not. Can you tell is it valid or not? Yes, sir, it's a thread object only. That's why what answer you are going to get? True itself is the answer. Okay, anyway. System.out.println T instance of Here object or not? What answer we will get? Instance of object or not? What answer? Is that true? Because every child object is by default what type? Parent type. That's why true. Next, system.out.println T instance of runnable or not? T instance of runnable or not? Every implemented class object by default is interface type. That's why in all these cases, can you spell out what answer we are going to get? In all, true is the answer, true itself is the answer, true is the answer. Are you getting? So how you can use instance of operator? Now example 1. Take this one. Take this example anyway. Take clearly. Thread T is equal to new thread. Take SOP of T instance of thread, T instance of object, T instance of runnable. True, true, true. It shall be the answer. Next, thread is the child of object. Thread implements runnable interface. Thread is the child of object. Thread implements runnable. Like. Can clear for all of you, right? Okay. Completed, I hope. Next, example 2. Of course, there is an important conclusion is also there. Example 2 here, see. Sir, I am taking thread T is equal to new thread. Sir, thread T is equal to new thread. Same thread object only. System.out.println T instance of T instance of, here I am taking string. Can you tell what is the answer we will get? T instance of string. What is the answer? Thread is a string type or not? What answer you can? Is nothing but false. Okay, this. But if it is a false, what is the speciality? Is nothing but no. We want to get a false. So the answer we are going to get compile time error, right? Okay, the code won't compile. What is the reason for that? Simple. To use instance of operator, compulsory there should be some relation between argument types. Can you tell T is what type? Thread type. String and thread. Is there any relation? No. So to use instance of operator, compulsory there should be some relation between argument types. If there is no relation, then what will happen is nothing but compile time error saying inconvertible types. Inconvertible types. So internally compiler is going to check, is this type, is it convertible to this type or not? Is nothing but. So thread unable to convert to string type. That's why. So found java.lang.thread required what are the required? java.lang.string. Make sure you people should aware, if you want to use instance of operator, compulsory there should be some relation between argument types. Is it clear, right? Okay, this say if there is no relation between argument types, maybe child to parent or parent to child are same type. If there is no relation, then what will happen is nothing but immediately we are going to get compile time error saying inconvertible types found thread required is nothing but string. Any doubt or any explanation is required? Okay, make sure. Now observe. So thread T is equal to new thread. System.out.println T, here just observe T instance of, just I am taking first example thread only. T instance of thread, like just have a look. T instance of object, T instance of string, T instance of runnable. Example 1, let me compile first. So perfectly this one is nothing but valid. There is no compile time error. Valid. What is the output? By default we are going to get a true, true, true like. But t instance of, here I am taking string, t instance of string. You know, immediately compile time error by default we are getting. Have you observed? So inconvertible types found thread required is nothing but string. Are you getting? So to use instance of operator, compulsory there should be some relation between argument types. If there is no relation, then automatically we will get compile time error, right? Is it clear, right? First add example. Have you added theory? No, right? At this point, to use instance of operator, to use instance of operator, compulsory, there should be some relation between, there should be some relation between argument types. Compulsory there should be some relation between argument types. Within bracket, either child to parent or parent to child, either child to parent or parent to child are same type, either child to parent or parent to child are same type, otherwise bracket close, otherwise we will get compile time error, saying inconvertible types, otherwise we will get compile time error saying inconvertible types. Okay, take this example. Better to take this example here. Yes, you are asking something.
Sir, in case of Boolean defined,
Same thing. Parent to child or child to parent are same type. Whether it is predefined or user defined, same rule. Take clearly. Inconvertible types found java.lang thread required java.lang string. So make sure you people should have clarity about this terminology, right? Can I complete it, right? Okay. Inconvertible types found like. Now the last conclusion about instance of operator. If you can take any class or interface X, analogy, if you can take any class or interface X, any class or interface X, null instance of X, it is always false. I get a null instance of X is always false. For any class or interface X, null instance of X is always false. Best example here, just observe this one. Sir, here I am taking null instance of thread, null instance of object, null instance of runnable. Are you getting? So here just null instance of thread, null instance of object, null instance of runnable. Like now let me compile this code. Have you observed? The code compiles fine. What is the answer by default we are going to get is nothing but false. So if we compare null with any class or interface, the result is always what? False. Okay, add. Take a note. For any class or interface X, for any class or interface X, null instance of X, null instance of X, for any class or interface X, null instance of X is always, null instance of X is always null instance of x is always false, is always false, false. Null instance of x is always false, false. That's all. So if you want example, just among these three or otherwise here only, let me take system example, only one. SOP of null instance of thread. What is the answer we are getting? False. Next, SOP of null instance of runnable. Any class or interface. What is the answer? False. Like. Right. So this is what instance of operator we have. Instance of operator. Next, keep submitting. Bitwise operators. Bitwise operators. Bitwise operators within bracket and or, okay, like, and or XR. That symbol is called XR, exclusive OR, and or XR operator, right? Now here listen this point well, sir. And operator, this one is nothing but what? And operator. Can you tell when and operator returns a true? If both arguments are true, so returns true if both arguments are true. Are you getting? Returns true if and only if both arguments are true. Like both arguments are true. Okay, this same. Sir, this one is nothing but R symbol. R symbol. Can you tell when R operator returns a true? If at least one argument is true, R symbol, either this or this. If at least one symbol is true, at least one argument is true, then returns true. Returns true if and only if at least one argument is true. At least one argument is true. Next, what is this one? Cap symbol. What is this one? XR. Are you getting? XR symbol. Exclusive R. XR means exclusive R. Can you tell when exclusive R returns true? When it returns true? You know, yeah, and R XR, exclusive R. Normal R means either this or both. Is nothing but like. But exclusive R means, so first one but not second, or second one but not first. So it means either first one or second one but not both. Either first one or second one but not both. You know. So somewhere I have in one book I saw. I have one animal is there. I have one animal. This animal can be dog or can be cat. Can be dog or can be cat, but not both simultaneously. Is there any chance of animal, cat and dog simultaneously? No. So, but not exclusive or, but not both. Either this or this, but not both. If the first one is true, second argument should be false. If the first argument is false, second argument should be true. If both arguments are different, then this one returns true. If both arguments are same, then this one returns false. Correct or not? So here returns true if and only if both arguments are if and only both arguments are different. If both arguments are different, true, false. False, true is nothing but XR returns true. Is it clear for all of you? Right? Now just observe this example well. Here see system.out.println SOP true and false. True true and false. SOP of true or false. SOP of true or false. SOP of true XR false. True XR false, like true and false. What is the answer? True and false. What is the answer? False is the answer. True or false? What is the answer? True is the answer. True XR false. What is the answer? Sir, both are same or both are different? Both are different. If both are different, then the answer is nothing but true by default. I hope you people can aware when AND operator returns true, OR operator returns true, XOR operator returns true. You should have clear clarity. Okay, take this part. Take clearly. Bitwise operators and a symbol meaning is nothing but and returns true if and only if both arguments are true. Returns true if and only both arguments are true. Next, R symbol returns true if and only if at least one argument is true. Next, exclusive or like AND operator or and XOR. Make sure you people should have clear clarity. True and false. True or false. True because at least one argument is true and both arguments are different, that's why true. And R XR. Can our terminology is clear, right? So bitwise operators like. Okay, just sometimes in the exam, maybe very rare to ask this type of questions and enter your room, but in the exam maybe a chance for SCJP or OCJP, there may be a chance. Yes, completed, right? Okay, now there may be a possibility to ask, maybe a possibility to ask the question something like, here see, SOP of 4 and 5. SOP of 4 and 5. SOP of 4 or 5. SOP of 4 XOR 5. Can you tell what the answer? Yeah. Ayo. Think a bit carefully and then tell the answer. True. Ayo. First, is it valid or invalid? That's what you have to identify. Valid or invalid? Valid. How many people are feeling invalid? Invalid comparative matter? No. Okay? Valid. Don't keep any doubt. Valid. Then what is the answer in the first case? True. What is the answer in the first one? True or false? First one? False. True. Second one? True. Last one? False. Okay? So here make sure the people who attended already, the people who are bringing Xerox copies, better to close, so that remaining people can think. If they can think, then they can remember the point well. That's all, especially. So the people who are bringing Xerox, can you please close and open fresh white notebook, so that you will get some clarity in your mind. Okay, just referring Xerox, there is no use. Make sure. Okay, don't tell the answers. I know in front of you answers may be there. Okay, not good. Now can you tell SOP of 4 and 5? 4 or 5? 4 XOR 5. Is it valid or not? Valid. In the first case, what the answer? True or false? True or false? True. Second one? Second one? False. True. True. Correct. Last one? False. Make sure Perfectly, these are valid, don't keep any doubt. But the answer is, first one 4 is the answer, second one 5 is the answer, last one 1 is the answer. Are you getting? 4, 5, 1 is the answers what we are going to get. We are not going to get true or false like okay this. If we apply for Boolean type, then the result is Boolean. If we apply for number types, then the result is number. Okay, we can apply these operators for integral types also. Is nothing but integral type, byte short, int long, only 4. We can apply these operators for integral types also. Okay, this if we apply for integral types, what is the answer? Here see 4 and 5. Yeah, observe 4 1 0 0. These operators are what? Bitwise. Correct or not? Bitwise operators, right? Now 4 means what? 1 0 0. 5 means what? 1 0 1. 1 0 1. Apply bitwise. The word bitwise. 0 and 1. What is the answer? 0. 0 and 0 0. 1 and 1 1. That's why 1 0 0 is nothing but 4. Next here 5. 1 0 0 1 0 1. 4 or 5. 1 0 0 1 0 1. Apply R operator. 0 or 1 1. 0 or 0 0. 1 or 1 1 is nothing but like. Getting? Next so 1 0 1 is nothing but 5. Next 4 XOR 5. Are you getting? 4 means what? 1 0 0. 5 means what? 1 0 1. Are you getting? 1 0 1. 0 or 1. What is the answer? XOR. If both arguments are different, then only result is true. Or then if both are different, 1. Both are same, 0. Both are same, 0. Then what is the answer? 1. I hope you can aware clearly. 4 5 1 itself is nothing but the answer. First add. We can apply these operators. We can apply these operators for we can apply these operators for integral types also. We can apply for integral types also. Okay, take this example anyway. Take this. SOP of 4 and 5. Completed, right? So compulsory you have to take this part also. 4 and 5. The answer is the 4 or 5 is nothing but 5 like. So we can apply these operators for Boolean type, and we can apply even for integral types also. There is no problem at all. We can apply everywhere. For Boolean types we can apply. For integral types also we can apply. Valid. Can I complete it, right? Okay. Now the next point, make sure. So keep subheading bitwise complement operator. Bitwise complement operator. Bitwise complement operator. Okay, tilde symbol within bracket, just bitwise complement operator, tilde symbol, right? Now listen. System.out.println SOP of negation of true. What is the answer? Why you are thinking this much? What is the answer? Negation of true. What is the answer? False. Yes, it is a big false statement. Compile time error we are going to get. Okay, compile time error, right? Because this operator applicable only for integral types but not for Boolean type. Are you getting? This operator applicable, bitwise complement operator applicable only for Boolean, or only for integral, but not for Boolean. So what compile time method? Operator tilde, okay, cannot be applied to Boolean. Is nothing but like compile time method we are getting. Operator tilde cannot be applied to Boolean type. Is nothing but compile time method, right? Now, so here if I can take system.out.println negation of 4 I am taking. Negation of 4 I am taking. Can you tell is it valid or not? Valid. For integral types you can apply. Forget about result. What is the result? We will analyze first at this point. We can apply this operator. We can apply this operator only for, we can apply this operator only for integral types, but not for Boolean type, Boolean type. If we are trying to apply for Boolean type, then if we are trying to apply for Boolean type, then we will get compile time error. Okay, at this example, SOP of negation of true. Operator tilde cannot be applied to Boolean. Is nothing but this is the compile time method we will get. Next one, SOP of negation of 4. Can you tell what the answer? SOP of negation of 4. What the answer we will get? Yes. SOP of negation of 4. And what the answer? 3. Because 4 means what? 1 0 0. 4 means 1 0 0. Sir, negation bitwise complement, right? Now 0 will become what? 1. 0 will become what? 1. And 1 will become 0. Now what the answer by default we are going to get? 3. Most of the people are going to feel like this, but the answer is -5. Okay, this is the answer we are going to get, not 3, because sir 1 0 0 will become 0 1 1. 0 1 1 means 3. Like some people are going to fail. No, the answer is what? -5. Let me show first, because you may not believe. Sorry is telling some wrong thing like. Okay, now here negation of true I am taking. Negation of true. Okay, here have you observed the code won't compile, because this operator applied only for integral types but not for Boolean. That's why operator tilde cannot be applied to Boolean. Clear? Negation of 4 I am taking. If I can take negation of 4, what will happen, Anna? Negation of 4 I am taking. What will happen? Immediately, negation of 4, -5 itself is the answer. Yes, valid, but -5 itself is the answer. Is it clear, right? Okay, this is -5 itself is the answer. Okay, so make sure you people aware. So how it is -5? You should have clear clarity. Do you want me to explain, or simply you can remember? Do you want me to explain internally how this my negation of 4 will become -5? Do you want me to explain internal? Yes, make sure you should have clear clarity, right? Sir, here 4 is by default what type? 4 by default what type? Int type. Every integral number is by default int type. Int means how many bytes? 4 bytes. 4 bytes means how many bits? 32 bits. 32 bit. Sir, for 32-bit complement you have to perform, not for 3 bits complement. Are you getting? First, how we can represent 4 in the memory? Like here, just observe 4. I want to represent in the memory. How we can represent in the memory? 4. Sir, is it a positive number or negative number? Positive. The most significant bit is a sign bit. Sign. If it is a positive number, it is a 0. If it is a negative number, it is 1. So 0 reserved for sign. Then the remaining 31 bits represent a value. What is the 4? How you can represent in 31 bits style? 0 0 0 0 0 1 0 0 is nothing but like. Are you getting? 0 0 0 0 1 0 0 is nothing but like. So here make sure. Sir, you should have clarity. Sir, 4. The most significant bit is the sign bit. This one is nothing but what? Sign bit, and the remaining bits represent value directly, right? This is the value. Now you have to perform, okay, complement for 32 bits, not for just only 3 bits. Now listen this one. So negation of 4 I am taking. Negation of 4. Now can you tell what will happen, Anna? 1 1 1 1 dot 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 1 0 1 1 1 1 1 1 and so on. Now most significant bit is what? 1. 1 means what, Anna? Negative number. Negative, because 1 means negative. If it is a negative number, the remaining bits represent value in 2's complement form. Observe a bit carefully. These words are very important. Sir, positive number, the value will be represented directly. But negative number, the value will be represented in 2's complement form. Now, what is the 2's complement form of this one? What is the 2's complement form of this one? Yeah, first find 1's complement. Sir, we have to find 2's complement. First find 1's complement. 0 0 0 0 1 0 0. Are you getting? So this 0 will become 1. 1 1 will become 0. Now add 1, because 2's complement, right? First 1's complement plus 1, 2's complement. 0 plus 1 1 0 1 0 0 0 0 and so on like. Can you tell what is the value of 101? 5 5, and it's already negative, so the output will become what? Minus 5. Is it clear for all of you, right? So don't think we have to apply only for 3 bits. No, we have to apply for what? 32 bits. 32 bits we have to apply. So this is what is the value of negation of 4 is nothing but minus 5. Okay, take this example. Take clearly. So observe clearly why it is negation of 4, why we are getting minus 5. Internal reason is nothing but like. So 32-bit complement we have to perform, not for 32-bit complement we have to perform, not for just 3 bits or 2 bits like. Can I hope up to this is the clear? Okay, so take a note. So all these things are memory level representations. Can I complete it, right? Note. Add the theory. Note. What is the theory is add. Do you know most significant bit is called what? Sign bit. 0 means what? Positive number. 1 means what? Negative number, right? Add. The most significant bit. The most significant bit acts as. The most significant bit acts as sign bit. Acts as sign bit. Next up. Sign bit. Next up. 0 means positive number. 0 means positive number. 1 means negative number. 0 means positive number, 1 means a negative number. 1 means a negative number. Negative number. Next. 1 means a negative number. Next. Positive numbers. Positive numbers will be represented directly. Positive numbers will be represented directly. Positive numbers will be represented directly in the memory. Positive numbers will be represented directly in the memory. Directly in the memory. Whereas negative numbers will be represented. Whereas negative numbers will be represented. Negative numbers will be represented. Indirectly in the memory. Indirectly in the memory. Indirectly in the memory. Indirectly in memory. In 2's complement form. In 2's complement form. In 2's complement form. That's all. So this one is bitwise complement operator. Is it clear for all of you? Okay, this is. But now there is one small twist. Here let me explain about this one. Sir, here whenever we are applying bitwise complement, suddenly you bring 32 bits. But he explained AND operator, OR operator, XOR operator only for 3 bits. So have you remember 4 and 5, 4 and 5, 4 R 5, 4 XOR 5. So you applied only for 3 bits. That's why we thought that in this case also 3 bits only. Actually, even in this case also 32 bits only we require to take. But whether we are taking 32 bits or 3 bits, there is no difference in the result in this case. Simple. Let me go for 4 and 5. 4 means what? Not 32 bits only. 4 means what? 0 0 0 0 0 1 0 0. 5 means what? 0 0 0 0 0 1 0 1. Apply AND operator. 0 and 1 0. 0 and 0 0. Next 1 and 1 1 1. And then what about remaining? 0 and 0 0. 0 and 0 0. Whether we are considering or not considering remaining bits, there is no change in the value. Correct or not? Because all are zeros. All are zeros. Whether we consider or not consider, there is no change in the value. That's why all these things are nothing but 0 0 0. But here 1 0 0. Are you getting? So that's why even need not be AND. Even OR operator also. Even XOR operator also. 0 or 0. What is the result? 0. 0 XOR 0. What is the result? 0 only. That's why whether we are considering or not considering, there is no change in the result. But strictly speaking, compulsory we should go for what? 32 bits, not for 3 bits. Clear for all of you, right? Okay, this is. So this is what bitwise complement operator, right? Okay, this is. Next, keep submitting. Boolean complement operator. Boolean complement operator. Boolean complement operator. Boolean complement operator. Okay, this is the symbol. Add Boolean complement operator. Okay. Now here just observe. Sir, system.out.println SOP of negation of 4. What is the answer? Negation of 4. What is the answer? True or false? Negation of 4 is okay. Make sure compile time error by default we are going to get. Compile time error. What is the reason for that? Okay, simple. Because we can apply this operator only for Boolean type. We can apply only for Boolean. By mistake, if you are trying to apply for integral types, compile time error saying operator negation cannot be applied to int. This is the compile time error we are going to get. Okay, this is. But if I consider SOP of negation of false, negation of false. What is the answer? SOP of negation of false. Yes, true itself is the answer. So not required to keep any explanation. So sir, if we consider this operator applicable only for Boolean but not for integral types, we can apply this operator. We can apply this operator only for Boolean types, Boolean types, but not for integral types. Only for Boolean types, but not for integral types. Integral types. Okay, here this example. SOP of negation of 4. SOP of negation of 4. That operator negation cannot be applied to int. Operator negation cannot be applied to int. Next, SOP of negation of false. The answer we are going to get what? True itself is the answer. I hope. Are you able to understand that? So what is the difference between, what is the Boolean complement, bitwise complement and bitwise operators, right? Can I complete it, right? Okay, now let me summarize these bitwise operators, right? Now let me summarize the bitwise operators what we have. Sir, here we covered and we covered AND operator, OR operator, XOR operator, AND OR XOR. Sir, we cover, okay, here see, these three operators applicable, these are three operators applicable for both Boolean and integral types. Applicable for both Boolean and integral types. Sir, this operator, this we covered this one also, right? Applicable for only integral but not for Boolean. Applicable for only integral types but not for Boolean type. Okay, so this one. Next, last operator, this operator. Okay, can you tell where we can apply this operator? Applicable only for Boolean but not for integral types. But not for integral types. Okay, make sure you people should have clarity, right? Okay, take this part. And OR XOR applicable for both Boolean and integral types. Next, negation applicable for only integral types but not for Boolean. Next, applicable only for Boolean but not for integral types. Only for Boolean but not for integral types. That's all, I hope. Clear, right? We can.
So that the value will be
That depends on that operation. 4 and minus 5. 4 means 32-bit representation. Minus 5 means 32 bits. In that the first bit will become 1. OR operator. 0 or 1, 1. So it is a negative number. Negative number means 2's complement. completed, right? Okay, that's all.